Alright, in this video we're going to do section 5.3, Properties of Logarithms. And this section we can do all in one day. This is a shorter section and we just have a few properties of logs to go over. And that's going to be the change of base formula to rewrite and evaluate log expressions. We'll use the properties of logs to evaluate or rewrite logarithmic expressions. And use the properties of logs to expand or condense logarithmic expressions. So most calculators have only two types of log keys, one for the common logs, base 10, and one for the natural logarithms, base E, or those are the ln logarithms. Although common logs and natural logs are the most frequently used, you may occasionally need to evaluate logarithms with other bases. To do this, we can use these following change of base formulas. So if we have something log base a of x, and we don't want to deal with that base a, we can pick any other base we want, call it base b, and break this up. We're going to have, the first is going to be log base b of this number x, log base b of x, and we're going to divide that by log base b of this old base number. And let me just throw some numbers in there. Say we had like log base 3 of 5. Well, we could change that into any log base we wanted. We could change that to log base 6 of 5 divided by the log base 6 of 3. So, the base 6, we can use any base we want, and this 5 will go into the numerator's log base 6, and this old base 3 will go into the denominator's log base 6. And again, we can do that with any base we want. I just chose 6 here arbitrarily. We could convert to base 10, just the common log of x over the common log of a. Again, the old base comes down here in the denominator, and this old number we were logging goes up into the numerator. And we can also, of course, do that with base e, the natural logarithm. So log base a of x is the ln of x over the ln of a. And we would just punch those in the calculator, divide, and get the answer. So change bases using the common log. So this is log base 4 of 25. We want to change this into a log base 10. And we don't have to write the base 10 if we don't want to. Just the log. And the 10 is there. It's implied. So we're going to put the 25 in the numerator and the 4 in the denominator. And now we can do this on the calculator. And that's the point. This we could not do on the calculator. Now we could do this. If we find the numerator, the common log of 10, 1.39794, and we divide that by the common log of 4, 0.60206, and if we divide those and round off, we're going to get about 2.3219. And let's do that same common log change with log base 2 of 12. Well, that's going to be the log of 12 divided by the log of 2. And we punch those in the calculator and get 1.07918 for the log of 12. And the log of 2 is 0.30103. And we divide those decimals and we round off and get approximately 3.585. So there we took a log of any base and converted it to common logs, divided, and got our answer. Example 2 is the same thing, but using the natural logarithms. And it's the same two problems. So log base 4 of 25 becomes the ln of 25 divided by the ln of 4. And if we get those as decimals, now the decimals we had here were 1.39 and divided by 6.02. If we do it to natural logs, it's going to be a little different. The ln of 25 is 3.21888. The natural log of 4 is 1.38629. And when we divide these and round off, we're going to get 2.3219. That is the exact same answer, 2.3219, that we got with the common log transformation. And here we did it with the natural logs. Again, these numbers, the numerator and denominator, were different with the natural logs than the common logs. But when we divided them, we got the same answer for the log base 4 of 25. And for part B, the log base 2 of 12 is the ln of 12 divided by the ln of 2. And the natural log of 12 is 2.48491, and we divide that by 0.69315. When we go back to the common logs here we did again, our numerator was 1.07, denominator 0.3. These numbers are very different, but when we do divide them, we get the same answer of approximately 3.585. So whichever method you prefer, common logs or natural logs, you should get the right answer. You know from the preceding section that the logarithmic function with base a is the inverse function of the exponential function with base a, so it makes sense that the properties of exponents have corresponding properties involving logarithms. For instance, the exponential property a to the 0 power equals 1 has the corresponding logarithmic property log base a of 1 is equal to 0. So here are some properties of logs in the blue box. Let a be a positive number such that it's not equal to 1, and let n be some real number. If u and v are positive real numbers, these following properties are true. We have the product property. Log base a of two things multiplied, we can break the two numbers that are being multiplied together, the u and the v, and break them out into their own separate logs, which are then added together. So the log base a of u times v becomes the log base a of u plus the log base a of v. Or if we do it with natural logs, the ln of u times v becomes the ln of u plus the ln of v. We have a quotient property. So the log base a of two things divided, u is the numerator, v is the denominator. So we can break this division up into a subtraction problem. Log base a of the numerator, u, minus log base a of the denominator, v. Or with the natural logs, the ln of u divided by v becomes the ln of u minus the ln of v. This was our numerator, and v was our denominator in the original problem. And the last one is my favorite, the power property. Log base a of u raised to the power n. That n, that exponent, we can just bring it down front and put it in front of the log to multiply by. So that becomes n times the log base a of u. And it also works with the ln. Here we have the ln of u to the n power. Well, that exponent, we can remove it from up here and bring it down front and now make it multiply. N times the natural log of u. And let's even think back here, you know, the very first property, the log of u times v. When we were multiplying bases, like bases, what did we do with the exponents? Well, when the bases were the same and we were multiplying, we added the exponents. Well, here we're multiplying two things, and we can break it apart into a addition problem, u plus v. When we divided like bases, x to the 7th over x squared, when we divided like bases, we subtracted the exponents. So here we are dividing, and we turn that into a subtraction problem. Log base a of the numerator minus log base a of the denominator. Remember, these logarithms are just rewritten exponents, so they have very similar properties. And we got a warning. There is no general property used to rewrite the log base a of a sum. Specifically, the log base a of two quantities added, u plus v, is not equal to log base a of u plus the log base a of v. It's almost like you want to do the distributive property. Log base a of the first term plus log base a of the second term. That does not hold true with logarithms. So example 3, write each logarithm in terms of the ln of 2 and the ln of 3. So let's see, here we have the ln of 6. Well, what's another way to write 6? Well, 6 is 2 times 3. So break the 6 up into a multiply, two terms multiplied together. Now we can break that apart. Since this is multiplying, we're going to break that up into a sum. The ln of the first term plus the ln of the second term. The natural log of 2 plus the natural log of 3. We've rewritten it in the terms we were asked to. B is a little different. The ln of 2 divided by 27. Well, we have a quotient. We have a division part here, so it's going to be the ln of the numerator. minus the ln of the denominator, 27. But, we got the first part in terms of ln of 2. We need ln of 3, and we got this 27. What can we do to 27? Well, 27 is 3 to the third power. And we have that exponent property, that this exponent can be brought down in front of the natural log. So we can rewrite this as the natural log of 2 minus 3 times the natural log of 3. So we have rewritten the original problem in terms of ln of 2 and ln of 3. Example 4. Find the exact value of each property, or of each expression, without using a calculator. So let's see, the first one is log base 5 of the third root of 5. So let's rewrite that, the log base 5, and the third root of 5. The third root of 5 to the first, turn that into a rational exponent. That becomes 5 to the 1/3 power. The exponent is your numerator, the index is your denominator. So now we have log base 5 of 5. Remember, we had those properties in the previous section where these sort of cancel each other out, and the answer is 1/3. Letter B is a little easier. We have the ln of e to the 6th minus the ln of e squared. Well, remember, logs and exponents are inverse operations and they cancel each other out. And more specifically, the natural log and the exponential e, the natural base, these cancel each other out. So we're left with 6 minus the ln of e cancels out here, and we're left with 2. And now the hard part, 6 minus 2 is 4. The properties of logs are useful to rewrite logarithmic expression in forms that simplify the operations of algebra. This is true because these properties convert complicated products, quotients, and exponential forms into much simpler sums, differences, and products. So in example 5, we want to expand the logarithmic expression. Well, let's see. Here we have the log base 4. And I'm going to write this a little differently. 5 times x to the third times y. All this string here is all multiplied together. We have log base 4 of a bunch of things being multiplied. So we can break that apart into separate logs that are added. Log base 4 of 5 plus log base 4 of x to the third plus log base 4 of y. And let's see, is there anything else we can do to simplify? The only thing I see is that exponent rule. That 3 we can drop down front. So we're going to have log base 4 of 5 plus 3 times the log base 4 of x plus log base 4 of y. So that was part A. In part B, we have a quotient, a fraction. So we have the ln of a numerator and a denominator. So we can do the ln of the numerator, square root of 3x minus 5, minus the ln of the denominator. And this square root, is there another way to write a square root? This is the square root of what's under it to the first power. So let's rewrite that as a rational exponent. The quantity 3x minus 5 to the half power minus the ln of 7. And now we can do our power again, bring that down front. So we have 1/2 the natural log of the quantity 3x minus 5 minus the natural log of 7. In example 6, we're going to reverse the process. Instead of breaking them apart and expanding the log expression, we're going to condense it. We're going to take what they give us and make it boil down into a more short and concise expression. So the first thing I want to do, well, one of the last things we did here is brought these exponents down. When we reverse the process, that's the first thing we want to get rid of. So here we do have some coefficients. This 1/2 is going to come up and become an exponent above this quantity. Oops. Above the x. And here we have a 3 that is going to go up and be an exponent here. So our first rewrite is going to be log of x to the half power plus the log of the quantity x plus 1 to the third power. And we have two log base 10s that are being added together, so we can turn that into a single log of these two quantities multiplied. So this is going to boil down into the log of the first quantity, x to the half. And let's even rewrite that. X to the half power is the square root of x. So let's rewrite that as square root of x, and then we multiply it by the other term, x plus 1 to the third. X plus 1 to the third power. So we took what was a couple terms added together and turned it into the log of a single value. So if it's addition, you turn it into two things being multiplied. And let's check out letter B here. The first thing I focus in on is this coefficient in the front. That's going to come up and become an exponent. The ln of quantity x plus 2 squared minus the ln of x. Well, we have two logs being subtracted, so that's going to turn into a quotient, the ln of a fraction. Our numerator is the first quantity, x plus 2 quantity squared, and the denominator is the second, just plain old x. X squared plus 2, or x plus 2 squared over x. Ooh, save the best for last, a little more complicated here. Letter C. As with any order of operations, I'm going to work inside the grouping symbols first. So I'm going to focus in on here. I have log base 2 of something plus log base 2 of something else. So that's going to turn into a log base 2 of those things multiplied together. So x times the quantity x plus 1. And out front here of the whole thing, we still have our 1/3. Well, we can distribute the x we have in here throughout the second set of parentheses. So we're going to have our 1/3 log base 2 of now x squared plus x. And now the last thing to take care of is this outer x or coefficient. That's going to come up and become our exponent. Oops, there it is. So this is equal to log base 2 of the quantity x squared plus x to the 1/3 power. And when that 1/3 comes up here, that is just a third root. The third root of x squared plus x. And I believe example 6 is it for this section. So here are some practice problems. The first two are expand the logs, break them apart. The next two are condense. And then for the assignment, finish up the worksheet. So pause the video, try these Huddle problems, and then turn it back on and see if you got them right. Okay, what do we do first here? Well, we got this outer exponent. I would distribute it to the numerator and denominator. So that's going to become the log of 6 to the 5th divided by 11 to the 5th. And now we have two things being divided, so we can turn that into the log of a difference. The log of the numerator, 6 to the 5th, minus the log of the denominator, 11 to the 5th. And now we could bring these exponents down front. And we'll have 5 times the log of 6 minus 5 times the log of 11. Now there is a slightly different way to do this, and we'll still get the same answer. Right off the bat, maybe you want to bring that exponent down front. So you're going to have 5 times the log of 6 divided by 11. And now inside the brackets, break that apart into a subtraction. The log of 6 minus the log of 11 and we'll close the brackets, and then we would just have to distribute the 5. So we'd have 5 log 6 minus 5 log of 11. It would be real easy just to, forget the brackets and have 5 log of 6 minus log of 11, and forget to distribute that 5. But if you're careful, both ways work. Now in the next one, we have an exponent, but the exponent is exclusive to the numerator. So we're going to break that apart right off the bat. The log of the numerator, 2 to the 4th, minus the log of the denominator, 5. And then we're going to address the exponent, bring it down front. 4 times the log of 2 minus the log of 5. And in 15 and 19, we are going to reverse the process. We will condense what we are given into a single logarithm. So first, let's get rid of the coefficients. The 4 is going to come up and become an exponent. This 4 is also going to come up and be an exponent. So we're going to have the log of 3 to the 4th minus the log of 8 to the 4th. And now we have a log minus a log, so that's going to turn into a quotient, the log of a fraction. And the numerator of the fraction is the first term, 3 to the 4th. And the second term is our denominator, 8 to the 4th. So we have the log of 3 to the 4th over 8 to the 4th. And if we want to go one more step, we can sort of make it look like example 3 from our earlier problem. We can sort of factor that 4th power out and have the log of 3/8 quantity to the 4th power. And the last one. This looks a lot like what we did up here, but it's a plus. And, well, let's go back to number 15 for a minute. We could have done it this way also. The first thing we could have done is factor it out of 4. Pull the 4 out, and we're left with log base 3 minus log base, or the log of 3 and the log of 8. I got to back up there. Log of 3 minus the log of 8. And now we work within the parentheses. We're going to have 4 times the log of, 3 minus 8. That's going to turn into a fraction, 3/8. And then we can bring this 4 up. And that would be the same answer we had before, the log of 3/8 to the 4th power. And number 6, now it's a sum. So we're going to turn this into a product, a log of a product. So the first thing I want to do is move those exponents up. So this is going to become log base 3 of u to the 6th plus log base 3 of v to the 6th. Log base 3 plus log base 3 is going to be another log base 3. And then the quantity that we're taking the log of is going to be this quantity times this quantity. U to the 6 times v to the 6. And then we could factor that exponent of 6 out. Log base 3 of the quantity, uv to the 6th power. And there we go. Again, the homework is we had a worksheet. Finish that up.